Hey guys, here's a brief explanation of each of your homework problems from last night. There were 28 white ducks swimming in a pond. Twice as many brown ducks flew in and landed in the pond. Then half of the white ducks flew away. How many ducks remained in the pond? How many ducks? So that's what I'm looking for. How many ducks, and if you've forgotten what remained means left. How many were left in the pond? Okay. All right. So if you draw a picture, I always like pictures because that helps us. So here's my pond. I know you're laughing right now, but anyway, here's my pond. There were 28 white ducks, so they're already there. I'm going to put 28 WD for white ducks. Okay. Then it said twice as many brown ducks flew in. So twice 28. Okay, so if I do twice 2 times 28, that would give me the brown ducks. So 28, so again, if you multiplied that, you should have gotten 56, because 2 groups of 28 is 56. Or if you added 28 plus 28, it's 56. Okay, so now 56 brown ducks came and joined them. So we've got quite a few ducks in there. Then it said after the brown ducks flew in, then it says then half of the white ducks flew away. So half of these flew away. So if we took 28 and divided it into 2 equal groups, okay, we know that 14 and 14 makes 28. So that's half of the white ducks. So half of them flew away. They're gone. So we don't have 28 anymore of white ducks. We have 14 white ducks. So we have 14 white ducks and 56 brown ducks. So how would I get the total amount that are still swimming in the pond? We would add 14 plus 56, which equals 70. Okay? So that's why the answer is 70. If you notice, you see lots of the numbers we were working with as answer choices. That's where it's very important to know what you're looking for. We were looking for the number of ducks. Doesn't matter if they're white or brown. We want to know how many ducks were left in the pond. Okay. Let me erase this. We'll go on to the next one. So get set up for that, as I do. I can get this. Okay. All right. Here we are, number 12. The planet Mercury measures 4,879 kilometers from one side to the other. The Earth measures 12,756 kilometers from one side to the other. What is the difference between the two measures? Here, the key. What is the difference between the two measures? So the measurements aren't the same. We can see they're different. And so if we're trying to find how they're different, we know that we need to subtract the two measurements. For right now, make sure the larger number is top, just like our graphic organizer we did earlier in the year. So 12,756. And if we subtract 4,879. So let's review our subtraction. Remember, if I can't take bottom from top, I need to regroup. So 9 is larger than 6, so I need to get help from the tens. 1 10 is worth 10 ones plus 6 more. This will give me 16. Now I can subtract. You notice I didn't go and try to regroup anything else. I want to do each place and then regroup. So 16 minus 9 is 7. Now I go to my tens. Can I take 7 from 4? No. So I've got to get 100. 100 is equal to 10 tens. And 10 tens plus 4 tens is 14. Now I can subtract my tens. I don't need to worry about anything except my tens right now. 14 minus 7 is 7. Now I go to my hundreds. 8, can I take it from 6? No. So I get 1,000. 1,000 is equal to 10 hundreds. And 10 plus 6 is 16. 16 minus 8 is 8. Now I have, can I take 4 from 1? No, I cannot. So now I'm going to grab a 10,000. 1 10,000 is 10 1,000s. And 10 plus 1 is 11. 11 minus 4 is 7. So the difference between these two amounts is 7,877 kilometers. Okay. Remember, I'm not going to do it, but if we wanted to check, we could add these two and see if we get our top number there, what we started with. Okay. All right, on to number 13. There were 4,536 people at the carnival. Each person bought 8 tickets. How many tickets were bought at the carnival? Okay. So, if we think about it, we're looking for the total number of tickets. So, we need to know how many each person bought. So, every person bought 8 tickets. And there were not just one person, but there were 4,536. So, that would be 8 tickets plus 8 more tickets plus 8 tickets plus 8 tickets. Every person bought 8 tickets. What's a faster way of adding all those amounts? We'll say 8 times 4,536 people. And if you remember, we did this by taking the number that's more than one digit, which is 4,536. We'll break that into its place value. So we would break that into 4,000 plus 5 is worth 500 plus, break it there, and 3 tens, which is 30, and then plus our 1, 6. Now we're going to have to multiply 8 by each of those, and this is easy because all we have to do is 8 times 4 is 32, and then we have 3 zeros, so that would be 32,000. Then we multiply 8 times 5 is 40, and this is where you have to be careful. That 0 came from 8 times 5, so therefore I've got to count these 2 zeros, so that's 2 more zeros, so 8 times 500 would be 4,000. 8 times 3 is 24, and I have 1 0, so that's 240, and 8 times 6 is 48. I'm not done yet. I need to add all these up. So if I added all these up, why am I going to do this is the question. Let me see if I can squeeze it in here. 32,000 plus 4,000 plus 240 plus 48. Okay. So 8 plus nothing, that's 8. 4 plus 4, 8. 2 plus nothing, 2. 4 plus 2, 6. And 3 plus nothing, 3. So 288. Okay. Pause if you need to take a close look at that. All right, let me erase what I have here. Slide this on up to number 14 so we can take a look at that one. Number 14, there are 638 students at the museum. All students will tour the museum. That's important. All students are going to tour, and they can have groups of up to 6, but no larger. So it's want to know, what is the least number of groups that can be used to tour the museum? So what are we doing with the students? We're breaking them apart into at least groups of 6. So we know it's a division problem, 638 divided by 6. Again, we'll use the forgiving method because it's easy groupings. Okay. I look at my hundreds. I have 600, so I'm able to put 100 in each group. Okay. Okay. So we have 6 times 100. If I do 100 groups, that would be 600. I can subtract this. I end up with still 38 students to put in a group. I know that 6 times 6 is 36. Okay, as close as I can get. But I still have 2 students. So here's the key. We are going to let all students. We cannot forget about these two students. So there's 106 groups. And then I'm going to need one group of 2. So basically I'm going to need 107 groups, or 107 groups to tour the museum. Okay. All right. Pause that if you need to, or rewind it if you need to hear that again. Okay. Let me erase that, and let's go on to the last problem, which is another equivalent fraction problem, which is the toy cars. And we've had this one too. So let's take a look. Lisa had a total of 12 cars. She gave her sister 3 of them. And I always like drawing on it so I can see exactly what I'm looking at. 3 cars. What fraction of Lisa's set did Lisa give to her sister? Well, I know there are 12 cars there, and she gave 3 of them to her sister, and that's what we're looking for, what fractional amount. Now I see that's not listed over here. So I need to see which one of these is equal. So would 3/4 be equal to 3/12? Well, can't be. You already have 3 here, so we should have 4 here. So 3/4, and we can see 3/4 is more than half. She gave away less than half of her cars. Let's try 1/4. Is 1/4 equal to 3/12? So how many times did we increase the number of pieces? 3 times. And how many will we increase here? 3. Is 4 times 3 12? Yes. So we have found the equivalent fraction. Now I would like for you to take a look at the picture and see, well, is this true? Can we separate her cars into 4 equal groups? We can. 1, 2, 3, 4. And remember, she gave her sister these 3. So she has given 1 out of those 4 groups to her sister. So those are equivalent. If you need to, pause, go back, and take another listen and look if you're unsure, or raise your hand if you need my assistance.